Hello everyone, welcome back to Data Engineering for Ultimate Beginner course and welcome to Learnetics, where we make data simple, practical and career focused. In last section, we have learned what is data engineering, and along the way, we also answered a few key questions like why data engineering is even necessary, why do we need to process the data in the first place, and what's behind the surge of demand in the data engineering. And finally, why does every company care so much about data? Well, so now you must be thinking, what next? Or maybe it's something like, wait a minute, 10 years ago, no one even talked about data engineering. So what changed? Why it suddenly such a big deal? You are thinking that, right? Totally fair. So in this video, let's break it down and really understand why data engineering becomes so important in today's world. So are you ready to dive in? Let's dive in. Alright, why is data engineering needed now more than ever before? Great question. Let's break it down. So in the recent past, a few things have changed drastically, and those changes are exactly why data engineering needed now more than ever. Let's break down this one by one. So the first change that has happened in the data engineering or data field is explosion of the data. A decade ago, data was small. You have a few databases, maybe CRM system, and that was it. But today, we are streaming in data from all kinds of sources like web application, mobile apps, IoT devices, sensors, click streams, server logs, you name it, you got it. We are generating terabytes of data every single day, and someone needs to organize that chaos. The next thing that has changed is complexity of modern system. Back in the day, a single monolithic system handled everything: storage, processing, and reporting, all in the one place. Or for the slightly more casual tone, back then, one big system used to do it all: store the data, process it, and even generate reports. But now, systems are way more complex and distributed. We are talking about cloud platform like AWS, GCP, Azure, microservices architecture, real-time tools like Kafka and Spark. To move data smoothly between all these tools, you need data pipeline. And to build those pipelines, yep, you guessed it right. You need a data engineer. Next change that has happened in recent past is the rise of analytics and AI. Today's business don't just want reports, they want predictions. They want dashboards that update in real time. They want AI models that forecast demand, detect fraud, and optimize prices. But here is the catch. These systems are only as smart or useful as the data they receive. What does that mean? If the input data is messy, outdated, or wrong, the output will be as bad. That means garbage in equal to garbage out. No clean and reliable data, that means no trustworthy insight, no accurate report, and definitely no meaningful AI. That's why data engineering is mission critical. The next thing that had changed in recent past is separation of roles. In the old days, one person might do it all: clean the data, run some queries, build a model. But now, the data world has specialized data engineer that builds infrastructure and pipelines. Data scientist focuses on model and algorithm, and data analyst turn data into business stories. It's like a relay race, and data engineers are the ones setting up the track. So, yeah, data engineering didn't just appear, it evolved because the data world got bigger, faster, and way more complex. And without data engineers, well, the whole system falls apart. Okay, let me guess what you are thinking right now. You probably thinking, all right, you have told me all about the story of data engineering, but how does actually workflow look like? Well, you are absolutely right. That's exactly what we are going to dive into next. Don't worry, we will break it all down step by step. All right, let's talk about data engineering workflow. Basically, how raw, messy data becomes clean, trusted, and ready to power dashboard, reports, or even machine learning models. Let's break it down step by step. So first step in the data engineering workflow is identifying data sources, the raw input, where data originates. Data start from all kind of sources like databases, MySQL or PostgreSQL, APIs, could be internal or third-party APIs, IoT devices. It can be a sensor, smart device, logs, etc. It can be a files like CSV, JSON, Parquet, or any kind of files that you can imagine. This is where the raw data is born. The second step in the data engineering workflow is data ingestion, bringing the data in data engineering scope. Now we bring this raw data into our system. Two main ways to do that. Batch ingestion, like pulling data every hour or every night using tools like Airflow, dbt, or even Python script. The second one is the streaming ingestion, capturing data in real time using Kafka, Flink, or similar tools. In this step, the tools that might be used is something like Airflow, Kafka, Logstash, or even Python for small scale use cases. The third step is raw storage, the landing zone. Once ingested data needs a temporary home, so we store it in a data lake like AWS S3, Google Cloud Storage, or Hadoop SDFS, or staging area in databases like Redshift or Snowflake. Think of this as a raw zone, basically a dumping ground before cleaning starts. The next step in the data engineering workflow is data processing and transforming. This is where the magic happens. We do here something like cleaning the data, normalizing it, aggregating the data, and joining this with the other data. Tools might be used in these steps are Spark, dbt, SQL, AWS Glue, Google Data Flow, or even Pandas for small tasks. The fifth step in the data engineering workflow is curated storage, that is also known as trusted data zone. Now the cleaned and processed data gets stored properly in data warehouses like Snowflakes, BigQuery, Redshift, etc. or structured data lakes like Delta Lake on top of S3. The next one is data modeling and serving. Finally, we save the data for real use. Create logical models like star or snowflake schema, build data marts or predefined views tailored for different teams, then serve this clean data to BI tools like Tableau, Power BI, or Looker, or data scientists using notebook or ML pipelines. The last and the final step in the data workflow is data consumption. After all the hard work of collecting, cleaning, and transforming data, it's time to use it. This is where all data gets put to work, whether it is for business analytics, dashboard reporting, insights, or decision making, or it might be for data science, feeding the data to machine learning models, or it may be for operations like real time decision making based on the fresh data from IoT devices, web apps, or transactions. Data consumption is all about taking that polished data and making it useful for the people or system who need it. And that's the entire data engineering workflow from raw data to insights. All right, let's play a quick game and you have to answer what does a data engineer actually do. Ready? You know this already from what we have discussed so far, but let's make it crystal clear. In data engineering, you are basically the architect, the builder, the behind the scene magician that makes data useful for analytics dashboard and AI. So what does that look like? Let's break it down. Being a data engineer, the first thing that you do is you build a data pipeline. Think of yourself as digital plumber. You move data from databases, APIs, logs, cloud bucket to warehouses, data lakes, machine learning system, or whatever you name it. And the tools of the trade is Airflow, Kafka, Spark, dbt, your mighty toolbox. The second thing you do as a data engineer is ingest and integrate data. You are not just moving data, you are also collecting it. That means batch ingestion, like daily scheduled jobs, or real time stream, like Kafka streams. And you are pulling it from everywhere: SQL, NoSQL, API, CSV, and of course, the spreadsheet that your coworker emailed you in the last minute. The third thing that you do as a data engineer is you transform the data. Time Time to clean up the mess. It's like data spa. Remove duplicates, handle missing values, convert formats like from JSON to Parquet, and business logic. This is where raw data becomes refined. The next thing you do as a data engineer is store data efficient. Where does all this beautiful data lives in? You make the call whether to you, like data lakes for raw unstructured stuff, or maybe data warehouse for clean structured query ready data. Being a data engineer, the next thing that you do is you ensure the data quality and reliability. Data is only useful if it's accurate and trustworthy. If your data is spits out garbage, your decision will be garbage too. So what do you do? Set up a validation rule to catch bad data. Monitor your pipeline to make sure everything running smoothly. Set alerts so you know the second something goes wrong. Because clean, reliable data equal to confidence decision and happy teams. The next thing you do is you automate and you orchestrate. No manual work here. You are the conductor of the data orchestration. Schedule jobs, handle dependencies, use orchestration tool like Airflow, Perfect, Daxter to make the magic happens while you sip your coffee. The next thing you do is you collaborate like a pro. You are not working in a vacuum. You sync up with data science. They might need the training data. You sync up with analysts. They might need the clean data for the dashboarding. You sync up with DevOps and SRE. They might need things that is not fall apart. You are the glue between raw data and business value. So there you go. That's the real job description of data engineer. It's part plumber, part chef, part guardian, part wizard. And if that sounds like you, then you are on the right track. Let's keep going. And that's wrap up the today's session on data engineering. We have covered the essentials from understanding why data engineering is crucial today to diving into the end-to-end workflow that turns raw data into valuable insights. Whether you are just standing or diving deeper into the world of data, remember, data is the foundation of smarter decisions. In next video, we are diving into a real world end-to-end example. We will get a little more technical and see how all this magic fits into modern day application architecture and why data engineering isn't just important, it's essential. Trust me, you don't want to miss it. Thanks for tuning in and stay tuned for more sessions ahead. Keep exploring and let the world of data work for you. Catch you in the next one.